All right, as we segue into our next section of material, the first thing we're going to cover is something called the greatest common factor. And as always, we start with a formal definition. The greatest common factor of two or more expressions is the largest expression that is a factor of all of the expressions. And so, it's more simply put, the largest factor you can factor out of all your terms. And so, always show that with an example. I have a review video for prime factorization up right now. We're going to use the concepts in how to do prime factorization to solve for the greatest common factor. So if you don't know what prime numbers or prime factorization is, go watch that video first and then come back, because we're going to use prime factorization to find the GCF going forward. If you do know what that is already, then we can begin with this example. So to find the GCF of 18, 12, and 6, or the greatest common factor, we want to factor out the biggest number we can, and while making sure that these are still whole numbers. And so to begin, we're going to do prime factorization. And just a little review for if you are shady on it but have seen it before. Prime factorization begins with the number you have, and then you can come up with any two factors. It can be any of them, because you're going to end up with primes anyways. I always just divide it by 2 if it's an even number. So let's say we have 9 and 2. So you want to split your number into 2 of its factors. If your factor is a prime number and this branch, you stop this branch here and nothing else happens. If this is not a prime number like 9, then you can keep going and you split 9 into its factors. The only other 2 factors 9 has other than itself and 1 are 3 and 3. And now 3 is a prime number, 2 is a prime number, so we stop all branches and we're done. Now 18 is going to have a prime factorization of 2 times 3 times 3. Now going on and doing that with 12, let's split it up into 3 and 4 this time. 3 is a prime number, so either way we stop right here. 4 can be split up into 2 and 2. So again, 12 will have the prime factorization of 2 times 2 times 3. And then 6, we can split it up into 3 and 2. Those are both prime. So 6 has a prime factorization of 2 times 3, or 3 times 2. Now, using prime factorization, we found these components of each of our numbers. Now, we can rewrite them, and it's suggested that we do. I'll write them right here. 2 times 3 times 3. It's not necessary, but it's easier if you kind of rewrite them underneath each other. Because then you can see how this next part becomes much easier. You want to find the greatest common factor, you want to take each prime factor that all of them have in common. So, and just circle them for now. So we have 2's. Every one of these numbers has a prime factor of 2. And then everyone also has at least one factor of 3. Now, 18, 12, and 16 don't share any other prime factors with each other. This one has a 3, this one has a 2. 6 doesn't have any other prime factors, it only has 2. But we have a 2 and a 3. So that means that we can pull out a 2 times a 3 from this, which is 6. And that is going to be our GCF. So our GCF is going to equal 6. So after you group whatever you have, if I have a 2 in common with all of these, I just take 1, 2. And I have a 3 in common with all of these, I take 1, 3. I multiply them together. And if I had more in common with all 3 of these numbers, I would pull out more, and I'd multiply them all together, and that's your GCF. Now you can kind of see this because just looking at 18, 12, and 6, well, the biggest number I can factor out of all of these while still having whole numbers is 6. Because if I factor anything out of 6 that's more than 6, I'm going to end up with a fraction, not a whole number. But 18 divided by 6 is 3. I'll write this. 18 divided by 6 is 3. 12 divided by 6 is 2. And 6 divided by 6 is 1. Now, conveniently, 18 and 12 are also divisible by 6, but you couldn't pull anything more than 6 out because, again, this 6 would turn to a fraction. So the greatest number you could factor out of all these numbers is a 6. And so it would be reduced down to these numbers. And so your GCF is 6. Now, kind of a formal, set of steps to do this is, you could say, step 1, complete prime factorization on all terms. So again, if you want a sort of methodology to do this every single time, then always complete a prime factorization. Number 2, collect common factors among all the terms. Obviously, we just did that. Again, see which prime factors each term had in common. And then 3, multiply all the common factors together, like we did here. And then 4, you're done. That's your GCF. And so with that, we have another example. So we have 48x cubed y cubed, 27x squared y, and 9xy squared. So leaving the variables alone for now, because they can't be prime factored in a sense, because there's nothing prime about variables. We don't know what the number is yet, but we can prime factor 48. So let's just make it easier for ourselves and say we'll divide it by 2 first. So split it into 24 and 2, that makes 48. This is prime, so let's do it again. 12 and 2 makes 24. This is prime, so we leave this branch alone. We'll do it again. 6 and 2, prime, and then 3 and 2. And so the prime factorization of 48 is 3 times 2 times 2 times 2 times 2. All right? And so that's the prime factorization of 48. Let's do 27 now. So this can't be divided by 2 because it's an odd number, but it can be divided by 3. So we'll split this up into 9 and 3. This is prime, so we leave this branch alone. And then 9 just gets split up into 3 and 3. So 27 has a prime factorization of 3 times 3 times 3. And 9, we just showed, is 3 and 3. So 9 has a prime factorization of 3 times 3. All right. Now that you've done your prime factorization of all of your actual integer numbers, you can list them above and below each other to make it easier for yourself. So 2 times 2 times 2 times 2 times 3. 27 is 3 cubed, or 3 times 3 times 3. And 9 is 3 squared, or 3 times 3. Now, another thing I want to point out is we have variables here. So when you're doing this kind of a separation by multiplication, also list your variables. So x cubed is just x times x times x. Y cubed is y times y times y. X squared is x times x times y. And this is x times y squared, which is y times y. All right. And now it is the same exact process. So having variables didn't change our process at all. We completed prime factorization on all of our terms. We will now collect common factors among all the terms. So we see that these two do not have any 2's. So we will not have any 2 in our prime factorization, or our GCF. But there is at least 1 3. So there's 1 3 here, 1 3 here, 1 3 here. And there's no more 3's, so we know we're done with the numbers, because this has only 1 3. This does not have any 2's, so 1 3 is the only number that these will have in common. However, that does not leave variables. So at least every number has 1x attached to it. So there's 1x here, 1x here, and 1x here. So we know we're going to have at least 1x also in our GCF. And as far as y's go, each of them at least has 1y as well. So there's 1y here, 1y here, and 1y here. So we're going to multiply by a y. Now after that, I could have lined it up better, but if you can see, this has 2 x's and 2 y's, this has 1 x, and this has 1 y. So there's not a single 2, 3, x, or y that's common among all 3 of these terms, and so we're done. We can't pull one common factor out of any more of these terms. And so our GCF is just 3xy. And then you can see that because if you divide 48x cubed y cubed by 3xy, you get 16x squared y squared. And then if you divide 27x squared y by 3xy, you get 9x. And 9xy squared by 3xy, you get 3y. And that division with the cancellation of variables we'll go over in a different section. I just want to prove to you that this 3xy is the biggest factor we can pull out without having fractions, because this has no more x's left, this has no more y's left, and I mean this has both, but these two didn't have any x's or y's left, so you couldn't pull out any more x's and y's. And so with that, if you have any questions, leave them in the comments, and if you thought this was helpful, then you should like and subscribe.